Hello everyone, this is Professor Robert Solis. Welcome to our next video lesson. We're going to be learning about how to create an application like this which allows the user to enter in 5 quiz scores, whether they are whole numbers or real numbers, doesn't matter. So as you can see here, 5 quiz scores have been entered, and let's assume that the highest quiz score is 100. Then when we click the calculate button, we're going to want to total all of the quiz scores. From that total, we're going to want to determine the percent, again assuming that 500 is the maximum because each of the different quizzes is worth 100, so 100 times 5 quizzes, that's 500 points. So in this case, 389 divided by 500 is going to give you 0.07780, but we want this in the percent style, so we want to make sure to format the string in such a way as it displays a percent style with 2 numbers after the digit. We also want to calculate the letter grade, so for example, if it's from 90 and above, that's an A. From 80 to less than 90, that's going to be a B. 70 less than 80, that's going to be a C, so forth and so on. Then we also want to take a look at all these quiz scores and determine which one was the smallest one and which one was the largest one. Perhaps the professor wants to say, I'm going to throw out the highest one, I'm going to throw out the lowest one, right? So we want to give them that option to calculate, or determine rather, what the min score is and what the max score is. And we're going to use this via a function called the math library.min and also .max. I'll get to that in just a moment. Alright, so here's some user requirements and some software requirements. I'll let you read those. I've already created the Visual Basic program, so let me show you that over here. So again, using Visual Studio 2008, the graphical user interface is pretty straightforward, so I assume that you could probably create this by now after all these lessons. And let me just go over some of the different names. So once you've created this graphical user interface, this text box should be TXT Quiz 1, this text box should be TXT Quiz 2, this is TXT Quiz 3, TXT Quiz 4, this one's TXT Quiz 5, this button is going to be BTN Calculate, this label is going to be LBL Total, this label is LBL Percent, this next label is LBL Letter Grade, this next label is LBL Min Score, and then finally we have LBL Max Score. So we have these labels, this button, and also these text boxes. We want to get rid of the min and max box, make sure that the title is Gradebook for this particular form, and that's about it, so pretty straightforward. Well, let me go ahead and double click on the calculate button, and what I want to do is to begin the code, and as usual we'll have a certain template, right? So for example here, I probably want to go ahead and create the declarations first. So let me put a comment here, and this will be the declarations area. Then at that point we want to obtain the user input. From that we're probably going to have calculation of the various grades, and then of course we're going to output the results. Okay, so a very general template of what it is that we're going to be doing. Declarations. I misspelled that. There we go. Okay, well, let me go back to the handout, and I give you a pseudocode of what to use, how to approach solving this problem, and also I give you the variables that I want you to use. So let me go ahead and declare these variables. So quiz 1, 2, 3, 4, 5. So let me start off with those. So I'm going to say dim quiz 1 as, and I'm going to declare these as doubles because a user could enter in a whole number or a real number, as you can see in the example here. So creating them as a double will cover both. And then we'll just do the same thing for quiz 2 as double, dim quiz 3 as double, dim quiz 4 as double, and then finally dim quiz 5 as double. Alright, so that takes care of the quizzes. It looks like I also have some additional variables such as total, percent, letter grade, min score, max score. So let's go ahead and start with total. So dim total as double. Let's see, what else do I have? Percent as double. Letter grade. Well, we're going to do the letter grade as a string, right? Because letter grade is going to be equal to the letter A, B, C, D, or F. Well, that wouldn't be a number, right? Like a double or an integer. That would be a string because a string is text. So the letter grade will declare that as a string. And let's see, what else do we have? Min score and also max score. Okay. So dim min score as double, and then finally max score also as a double. All right, well, the reason why I'm declaring total as a double as opposed to, say, for example, an integer, right? I don't want to declare this as an integer because basically the quizzes, if I'm going to total all of them up, and if this was something 0.1, 0.1, 0.1, 0.1, right, and whatever, if I added all these up, it'd be something 0.5. Well, if I save this as an integer, right, if I add all these up, save it into the total variable, it's not going to count the fractional part, it's only going to count the integer part. So I have to be consistent and use a double for my total. Same thing with percent, right? We know obviously that's going to be 0 point something. So I'll leave that as a percent. Letter grade, obviously, I just discussed that. And then min score and max score. Well, hey, it's going to be, one of these is going to be a minimum, one of those is going to be a maximum, so I have to set that up as a double as well. All right, it looks like I've declared my variables, so let's go ahead and obtain the input. So quiz 1 is going to be equal to the conversion, convert to double of txt quiz1.text, and really it's the same thing 4 more times, so let me just go ahead and copy and paste this. Control C, Control V, Control C, Control V, Control V, okay, good, and then I'll just change these quiz scores numbers, so this will be 2, and this will be 2, this will be 3, and 3, quiz 4, quiz 4, quiz 5, and then finally over here, quiz 5. And just again, to make sure that you understand what's happening here, we are going to take from these text boxes. So this is txt quiz 1, txt quiz 2, so forth and so on. People are going to be typing in numbers into these, but these text boxes are treating those numbers as text. So I'm going to take the text from that text box, convert it into a real number that is a double, and then I'll assign it to quiz 1, which already is a number, as you can see up here. Same thing with the text property for txt quiz 2. For that text box, convert it to a number, and then assign it to this variable. And I'll do the same thing for the rest of these, right? I'm working from right to left. I think I had mentioned that several times already. Whenever you see that assignment statement, you're always working from right to left. Put this into this. That's the way you should read it. All right, so I've obtained the user input. Now I'm ready for my calculation, and that's where the pseudocode comes in my handout. So I say use, that should see the word use. Use the following pseudocode to determine the letter grade. If the percent is greater than or equal to 90, then it's an A. If it's greater than or equal to 80, then it's a B. If it's greater than or equal to 70, it's a C, so forth and so on. All right, so let's do this. First, I need to calculate the total, right? So the total will be equal to quiz 1 plus quiz 2 plus quiz 3 plus quiz 4 plus quiz 5. Okay, so now that I've determined the total, I can calculate the percent, right? So in this case, the percent is going to be equal to the total, so percent will equal to the total divided by 500. All right, let me talk about this number 500. Now, when you're actually typing in a number like this is called hard coding. There's pros and cons to this, probably more cons than there are pros. What if, for example, I decide, you know what, I think every quiz is now going to be worth 200 points for whatever reason. Well, that 500 is going to throw me off. So maybe instead of hard coding, that is just simply typing a number here, maybe I should create a variable and then just say whatever the max score is that's possible for, or what the total score is for all the quizzes, right? Total possible, perhaps. So let me go ahead and create another variable over here. I'll say, how should I phrase this? How about addition of all quizzes, or the sum of all quizzes. That's a better one, right? So sum of all quizzes. And I'll save that as a double, and I'll initialize that to 500. Because I know that right off the bat, since I told you at the beginning that all the quizzes are worth 100 points each, well, that's going to be 500. So now I have a number assigned to a variable that's going to save it as the maximum total points possible for all the quizzes when you add them together. If for whatever reason the professor says, hey, I'm going to make this so that it's 200 points maximum, well, in that case we can just change it in one spot and it'll change in the rest of our program. So this is probably a more elegant way of approaching this type of problem, and what I'll do is I'll just take this and I'll replace this 500 here with this. So now total is going to be divided by whatever the sum of all the quizzes is, and if for whatever reason that changes, if I change it here, notice it's going to change it here as well. So again, try not to hard code, which is what I did previously. You're going to try to create a variable to set that equal to a certain number, and then we can use that number throughout our program. Okay, well now that I've determined the percent, I can at this point now calculate the letter grade. So the letter grade will be based on this. So if percent is greater than or equal to 90, all right? If percent is greater than or equal to 0.9, then what do I have here? Letter grade is equal to A. Okay, that's a variable that we already created. So letter grade is going to be set equal to A. Else if percent is greater than or equal to 0.8, then letter grade is going to be set or assigned B. And why don't I just take this and just copy and paste a couple more times. So copy this, paste here, and this is going to be 70%, and that'll be a C. Enter, copy and paste. This is going to be 60%. That'll be a D. And then if all else fails, else letter grade is going to be assigned the letter F. All right, let's talk about this. Now I gave you the answer, right? So that's easy enough to do this. But why don't I dive a little bit deeper into the reasoning why I did this? Okay. The reason why I set it up like this is as follows. Let's assume that a person gets all 80s, right, on their quizzes. So that means they get an 80%, right? So the percent will be calculated to 0.8. All right, if percent is greater than or equal to 0.9, well, that's not going to be true because the person got 0.8 for their percent. So this is false, so we try the next one. Okay, now by trying this next one, what do we know before we even execute this statement? What we know for sure is that the grade will be less than 0.9. Make sure you understand that. If we are trying this statement, because this one's false, right? So we check this out, this is false. We are about to ask the question, is percent greater than 80? Or 0.8, I should say. Now, if that is the question that we are asking, we have already determined that the percent must be less than 0.9 because we just checked to see if it was greater than or equal to 0.9. If that's not the case, then it must be less than this. So what we're really saying here at this statement is that the percent must be, if it's true, greater than or equal to 0.8, and we know for a fact it's less than 0.9. Now that's perfect. Let me put a little comment over here. So I'm saying this. We know for a fact that the percent is greater than or equal to 0.8. We're going to find that out. And the percent is also going to be less than 0.9. Now, this part, I didn't ask that in the else if statement. I asked this portion right here, right? Is the percent greater than or equal to 0.8? But this is implied, right? This is implied if this is false. Let's say that this is 0.8, okay? Is 0.8 greater than or equal to 0.9? False. So what do we know right off the bat? Percent has to be less than 0.9. Otherwise, if it's greater than or equal to, this would be a true statement. And if it's a true statement, let's give the student an A. So, do you see how there's a reason why I started off with 0.9, and then I went to 0.8, and then I went to 0.7? Tell you what, let's experiment with this a little bit, okay? What if I did something like this? What if I took this else if statement and put it over here? Let's just play around with this a little bit just to see what happens. Now, as you can see, programmatically speaking, there is nothing wrong with my code. Syntactically, it's okay. You don't see any blue squiggly underlines in there, do you? It's fine. But this is a major logical error. And here's the logical error. Let's assume, let me just put a little comment here. Let's assume that the percent is equal to 0.85, say for example. Okay? We do all our calculations over here and over here. It comes out that percent is equal to 0.85. All right. Is percent greater than or equal to 0.9? Well, no, it's not. 0.85, which I just told you percent is equal to, 0.85 is not greater than or equal to 0.9, so therefore this is a false statement. Well, at this point, we're going to execute the next ElseIf statement to see if this is a true statement. Okay, percent, which is 0.85, is 0.85 greater than or equal to 0.6? Yep, that's a true statement. 0.85 is in fact greater than 0.6. Well, since this is a true statement, let's give the student a D. Now, if any of you got a 0.85, would you like me giving you a D? Absolutely not. Boy, you would have a conversation with the dean complaining about my unfair grading standards. Here's why. My logic is not correct. I should not have evaluated this second. Something else should have been evaluated second. So do you see how the logical placement of these is very important? This is unfair for me to give the student a D, even though this is a true statement, that 0.85 is in fact greater than 0.6. So here's a very important lesson. These statements have to be placed in a certain logical order. Now, the logical order that I used is as follows. So first, let me restore order to the universe here. Put this back over here and get rid of this extra space. Okay, so now here's what happens. The student gets a 0.85. Is 0.85 greater than or equal to 0.9? False. Is 0.85 greater than or equal to 0.8? That's a true statement. It is greater than or equal to it. Therefore, the student earns a B, which is correct. Right? So notice how I went from 0.9 to 0.8 to 0.7 to 0.6, and then finally, if your percent is not greater than or equal to 0.6, then it must be less than 0.6, and if it's less than 0.6 or 60%, you deserve an ElseIf, I should say. So else letter grade is equal to F. And that's the whole beauty behind the if statement. You have to arrange it in such a way as that it logically makes sense. Let's fool around with this thing a little bit more. What if I did something like this? What if I said if percent, let's see here, how about this? I'm going to mess around with these so that I'll put this underneath this. And I'll say ElseIf, and put this over here on the top. And let's say that something like this. And then we'll put this on the top. Boy, I'm really butchering this one. And let's see here, something like this. So if, and then let's see here. I'll say if percent is less than 0.6, then, and then you get an F. Okay. Okay. So what we're doing is this. I'm turning things around, right? We're considering less than 60%, greater than or equal to 60%, greater than or equal to 70, greater than or equal to 80. Do you see how I'm basically flipping things around? I'm wondering, is this okay? Is it okay to do something like this? Well, let's see. Again, let's assume that the student got a 0.85. Okay. Is the percent less than 60%? That's a false statement, so we know that you don't get an F. Fair enough. All right. Else, if the percent is greater than 60, well, the percent is 0.85. Is 0.85 greater than 0.6? Yeah, that's a true statement. 0.85 is greater than 0.6. Therefore, your letter grade is D. Is that okay with you guys? You're going to get a D if you get a 0.85. So again, do you see how this logical order does not make sense? It is not a sequential order. Sequence means logical order. This is not in sequential order, so this is erroneous. This is a tremendous problem. Why? Because I've created a logical error. Notice that there's no programming mistakes. Programmatically speaking, this thing works. Logically speaking, it doesn't make sense, and these are the worst type of errors to create. They're called logical errors. Errors in thinking, errors in the way that you have laid out your program. These are very expensive mistakes, and these typically refer to as like say for example when Windows has SP1, Service Pack 1, or Service Pack 2, or Service Pack 3, whatever. It's these kinds of errors that have usually been the problem, logical errors. So we got to be very careful about these. All right, let me go ahead and undo then so I can restore order back to the universe and go back to what I had before, which was something like, I think something like this. And actually, let me go Control Y. Here we go. Okay, so this, I hope that that lecture was important and that it was understandable in that your logical order for your if statements are very important. And I think that's it in terms of our if statement. So I don't want to just simply give you the code. I want to explain to you how it works. All right, well, once we finish with that, now let me see here. So I have the total, I have the percent, letter grade. Now, min score. Let's work on that. Okay, so let me go back over here to Visual Studio. And let's work on the min score. How are we going to solve for the min score? Well, I suggest that we use the math.min function. All right, the math.min function is really cool. Check it out. You're going to give this thing two numbers. You'll give it one value, comma, another value. So, for example, if I gave it quiz1, comma, quiz2, close quote, or close parens rather, right now, min score would be the minimum of these two. So if this is 1 and this is 2, min score is going to equal to 1. If this is 20 and this is 40, min score is going to equal to 40. In other words, math min is going to return the minimum value of one of these two. Whichever one is the smallest one, that's the one that's going to be returned and assigned to min score. Here's the problem. How many quizzes do I have? I have 5 quizzes. So I need to somehow shoehorn 5 quizzes into the mathmin function. Here's the problem. Mathmin requires 2 parameters, right? 1, 2. That's all it can take. It can't take 5 parameters. So let me share with you the trick. What we're going to do is basically substitute in. So I'll do this. I'll say math.min, parentheses, quiz2, comma, quiz3, close quote. All right, so consider this. This is the first mathmin function, right? The minimum is going to be determined here first. Which one's smaller, quiz2 or quiz3? Let's assume that quiz3 is a smaller one for whatever reason, right? Okay, so quiz3 is smaller, so that means that quiz3 is now going to be the parameter here. Well, now this mathmin says, okay, which one's smaller, quiz1 or quiz3? So do you see how that works out? By putting mathmin quiz1, quiz3, or quiz2, quiz3 as a parameter instead of quiz2, I'm now able to determine the minimum between 5 numbers. Or 3 numbers in this case, I should say. Well, what if I do this? Let's take that quiz3 and let's put math.min, parentheses, quiz3, comma, quiz4, close parentheses. What have I just done right now? Well, first we start with this inner function. You always start with the inner function first whenever you're dealing with parentheses, right? So would you agree that this is the innermost function right here? And what is the smallest one, quiz3 or quiz4? Once it determines that, then it's going to say, okay, what's the smallest of quiz2 and the result of either quiz3 or quiz4? And then it's going to say, okay, let's solve the outer one, which is what is the minimum of quiz1 and whatever the result is here. So I'll tell you what, let me break it down like this. Let's say that I ask the question, which one is the smaller one, quiz3 or quiz4? Let's say that quiz4 ended up being the smaller one. So quiz4 is the smaller one. Well, now the next question being asked is, which one is the smaller one, quiz2 or quiz4? And let's again say that quiz4 was the smaller one, just for argument's sake. And then, once again, which one is the smallest one, quiz1 or quiz4? Let's say that quiz1 is the smallest one. Well, now quiz1 gets assigned to min score. Okay. So I hope that that makes sense. We have 5 quizzes, though, so I better change this to mathmin quiz4, quiz4, comma, quiz5, and then add a parentheses over there. All right, so now I have just shown you the technique of how to take a function that takes 2 parameters and how you can extend it to have as many parameters as you want by simply substituting them in. So instead of putting quiz4 here, I put mathmin quiz4, comma, quiz5. Whatever the minimum of this is, that will now be compared with quiz3. Whatever that minimum is, it'll be compared with quiz2. Whatever that minimum is, it'll be compared with quiz1. Okay, so that's one way of using the mathmin function to determine what the minimum score is. Now there's other ways that we could have done this too. Like for example, I could have said something like this. I could have used a bunch of if statements. I could have said if quiz 1 is, if quiz 1 is less than quiz 2, quiz 2, then, okay, so if this is the case, if quiz 1 is less than quiz 2, then maybe I could say something like, well, let's determine if quiz 2, or quiz 1 rather, is less than quiz 3. Else, or if quiz 1 is less than quiz 3, right? Then, and if quiz 1 is less than quiz 4, then, and so forth and so on. Now, I haven't discussed this yet. This is called nested if statements. This if statement is nested inside of this if statement. This if statement is nested inside of this if statement. I haven't quite gotten there yet with you guys yet in terms of how to handle nested if statements, but in essence, this is another way I could have solved this. It's going to be a little bit longer for me to solve something like this, but it is possible. So take my word for it. I think if you were to understand and re-listen to my lecture about how this thing works, it's going to save you a ton of time. Well, in the same fashion, max score is going to equal to math.min, or max in this case, right? So the max returns the maximum of 2 items. So it's either going to be quiz 1 or quiz 2. But wait a minute, I've got 5 quizzes, right? So this really is going to have to be math.min, or max I should say, not min. Quiz 2 and quiz 3, right? No, we have 5 quizzes. So math.max, quiz 3, and quiz 4, parentheses. Okay, 4 quizzes, so this one is going to be math.max, parentheses, quiz 4, comma, quiz 5, close parentheses. And by the way, this is a misspelling. That should be quiz. All right. So once again, when we have this entire expression, what will be evaluated first? Whenever you're dealing with parentheses, the innermost parentheses is going to be evaluated, which means this is going to be evaluated first. Whatever the result of that one is, then we go from this parens to this parens, which includes this math function, which is going to find the minimum of those 3. And then we're going to go to the next outer parentheses, which will solve for the minimum of those 4. And then we go to this outer parentheses, which will solve for the minimum of those 5. Right? So that's how we solve min and max. Well, now we're ready for the output. So LBL, what do we see here? The first item is the total. Okay, so let's see here. LBL total dot text is equal to the conversion to string of whatever the total is. Okay, so take this number, convert it to a string or to text, and place it into the text property of this label. So in other words, put it into here. Okay, how about percent? So LBL percent dot text. All right, what are we going to put into here? Well, the percent is this number right here, percent, right? But notice that that number needs to be represented in percent style. Right now we have 0.7780, say for example. But that's not what we want. We want the percentage dot 2 additional numbers after the decimal point and the percent symbol. Well, the way that we achieve that is as follows. Dot to string. Quote, parentheses, quote. I want this in the percent style, and check this out. I want 2 numbers after the decimal point. Close quote, close parentheses. That's how you do it. I want the percent style. That's what this P right here represents. And I want 2 numbers after the decimal point. All right. Let's see, what else do we want? The letter grade. Okay, so the letter grade is simply going to be LBL letter grade dot text, and that's going to be letter grade. Now I don't have to do any conversion here. The reason why is because letter grade is already a string. Watch, if I hover my mouse pointer on top of this, it's a string. I'm putting a string into a string, so it's okay like this. Next, min score and also max score. Okay, so LBL min score dot text property. Now this I do have to convert dot to string. That'll be min score, and then LBL max score dot text. Again, we're going to do some conversion to string. Whoops, sorry, to string and max score. All right. So let me just describe what's happening here. This is a double, as you can see here. It's a real number. Let's convert this into a string. Then I'm going to assign it to the text property of this label. Same thing with the max score. Let's take the max score number, which is it's a double. It's a real number. Let's convert this into a text or to a string. Then assign it to the text property of the label. Because labels can only have text properties. Labels and text boxes and buttons, so forth and so on. They can only have text. So that means I have to convert it to a string. All right, I think that's it. Let's run the code and see what happens. All right, so here's our program, and let's start to enter some scores like 90, 80, 70, 60, 50, say for example. Let's click calculate. Well, this is going to be 350 points. Is that right? Well, let's see here. That's 170, 240, 300, 350. Yep, that's okay. Total works. And yep, 80, 90, 70, 60, 50. The percent is going to be 70, so that's correct. Notice how it gave you the two numbers after the decimal point rather, and also the percent symbol. And the average of, or not the average rather, but the letter grade is C. The smallest of these 5 scores is 50. The largest is 90, so everything works. Let's change things around. So what if I had a 50.5? And I don't know, let's just make up some numbers here. 99.5 and 100, say for example. So let's calculate this. You know, this is terrible here. Let's try something else here. How about a 90 there? There we go. Well, maybe I didn't get such a low score there. I got an 89. Oops. All right, click calculate. All right, so the total of all this is 457. Okay, and the percent is 91.40%. That's an A. The minimum score is a 78.5. Let me verify that. Yep, 78.5 is the smallest, and 100 is the largest. Looks okay. Yep, everything is working fine. Let me close this. If you want to investigate how the code works step by step, then what you would simply do is place a breakpoint. Now, typically you don't place breakpoints at comments, and typically you don't place breakpoints at declarations. Typically you place a breakpoint somewhere where there's an actual assignment taking place, something other than dimensionalizing or comments, right? So I will place a breakpoint right here with the first assignment statement, and then I will start the debugging. Now, what this allows you to do is after you've placed some numbers into the various text boxes and click calculate, this will allow you to go through the code and investigate to see what's happening step by step. And I highly recommend that you do this so that you can get used to debugging code, because as you develop problems, whether it's syntactical or logical errors, most likely it's going to be logical errors, and this is the tool or the technique that will help you to debug, that is to get rid of the bugs in the program. So here I have a text. Okay, the text box has an 80 in it. Let's convert that to a double and put it into quiz 1. So nothing's in there in quiz 1 right now. As soon as I click step over, then quiz 1 is going to be equal to 80. And you can see that down here in the autos section. Here it is. Quiz 1 is equal to 80. Let's go to the next text box. So the next text box is 90. So I put 90 into here. Perfect. The next text box is 90. I'm going to put that into the quiz 3 after I click step over again, and step over one more time. So let me just verify that these are all 90. So I'm just going to hover my mouse pointer on top of all these. This one actually was the only one that was 80. This is 90, this is 90, this is 90, this is 90. Okay, look, looks okay. All right, this next statement is going to take 80 plus 90 plus 90 plus 90 plus 90, and it's going to put the answer into total. Currently, total is equal to 0. Right? We haven't assigned anything to this. But after I click step over, now look at this. total is equal to 440 points. All right, 440 divided by 500, and remember this, we assigned it and initialized it up here. We said sum of all quizzes, and we're all assigning it to 500. Well, so 440 divided by 500, what will that percent be? Well, let's click, step over, and we find out the percent is equal to 0.88. Well, is 0.88 greater than or equal to 90? False. So it should skip this one and go to here. Is 0.88 greater than 80? That's a true statement, so it should go to this letter grade is going to be assigned the letter B. Let's see. Yep, sure enough, it goes into the if statement. Now, after this, here's what's going to happen. I'm going to predict it. Actually, it's not that big of a deal. All we're doing is we're saying since this was true, and we are now doing the true part of the if statement, it's going to jump and skip this, it's going to skip else, and it's going to go to right to end if. Watch this. So I click step over, boom, right to else if. It skips over all the other things. If you don't understand that, go to the previous lectures on the if statement that I've explained. I went into great detail explaining how it is that it's going to skip over all those other if statements. All right, at this point now, let me click the step over button. Now we're going to calculate the min score. Again, make sure you just click step over, and this will calculate the min score and also the max score. And then finally we have our output statement. So it's going to put this into the text, the label. It's going to put this into the label, so forth and so on. Let me just go ahead and click continue so I don't want to step by step anymore. I want to just go back to my program. So I'm going to click continue. So here's the program. Looks like everything's working. Let me go ahead and click close. And that is it. So I don't need that breakpoint there. I can go ahead and click that. And that is it. All right, so this is Professor Robert Solis. I hope this has been helpful. Have a good day. See you next time.